We have a specific cultural image of a highly intelligent person. They operate in pristine environments, move with absolute certainty, and keep everything perfectly filed. Society evaluates cognitive capacity using strictly external metrics. We assume that a sharp mind equals a spotless desk, immediate answers to complex questions, and the ability to seamlessly navigate a crowded room. However, data from cognitive psychology shows these aesthetic standards of neatness and speed rarely align with how high-level processing actually functions. Behaviors often diagnosed as chaotic, eccentric, or disorganized are actually specialized mechanisms. They are observable markers of an optimized neural architecture. This comparative model demonstrates the disconnect. On the left is the social expectation of intelligence, a linear, clean checklist. On the right is the cognitive reality. The physical environment may look messy, but the internal logic tree is firing with efficiency, mapping multiple variables simultaneously. To understand this mechanism, we can map 6 specific, seemingly strange behaviors directly back to their functions in the brain. First, the tendency to chronically overthink, paired with sudden, intense obsessions that vanish as quickly as they appear. Second, holding active conversations with oneself and maintaining strict order in some areas while letting others collapse into physical clutter. Finally, the rejection of casual small talk and a strong preference for solitary walking. Intellectual capacity functions as an internal metabolic strategy, operating independently of external social conformity. When someone pauses to analyze every possible angle of a simple decision, observers often label it as anxiety or chronic indecision. The formal psychological mechanism driving this behavior is known as cognitive complexity. This decision matrix shows the difference. The misconception assumes a fast line from problem to solution. The high IQ mind builds a multidimensional problem space, generating a dense web of variables. Expanding this space eliminates hidden risks, locking in the final path. This same demand for comprehensive data drives another common trait: falling into short, intense bursts of deep obsession over seemingly random topics. Short-lived, intense obsessions mark a hyperactive curiosity system at work. It is driven by a specific biochemical loop. The brain receives a dopamine reward specifically triggered by the rapid acquisition and synthesis of new, complex information. Once the underlying system of that topic is mapped and the informational threshold is met, the interest shuts off and the mind moves to the next target. Observers see a string of abandoned hobbies and assume a lack of commitment. In reality, the brain has successfully executed its mission. It extracted the structural logic it needed and moved on. Both hesitation and obsession function as data-gathering strategies designed to maximize accuracy before a final decision is executed. This constant pursuit of accuracy creates a massive internal processing burden, which leads to physical coping mechanisms. Take self-talk, a habit often viewed as eccentric. In clinical psychology, this behavior is studied as verbal reasoning. When a high IQ mind juggles abstract variables, internal cognitive load spikes. Vocalizing the problem acts as a mechanical release valve. Overlapping abstract thoughts are forced through the physical mechanics of speech, converting complex ideas into a strict sequential format. Linearizing these thoughts prevents the brain from cycling back through the same abstract data points repeatedly. This creates a definitive path forward, allowing the mind to arrive at a solution faster while protecting critical working memory. This strict prioritization of mental resources also explains the disorganized genius or selective messiness. Maintaining universal aesthetic organization across every aspect of life demands a massive expenditure of physical and mental energy. To optimize that energy, highly intelligent individuals consolidate their order. They build flawless organizational systems exclusively in high-priority domains, like digital file hierarchies or complex logical frameworks. They deliberately allow physical entropy to take over their desks or living spaces to conserve mental bandwidth for abstract problem-solving. Self-talk externalizes working memory. Selective messiness preserves energy. The resulting environmental chaos is the calculated trade-off for maintaining a functional internal structure. Society expects individuals to effortlessly mingle and network, yet those with exceptional cognitive processing frequently avoid casual small talk. Social withdrawal functions as a defense mechanism, protecting the brain's processing capacity from the high metabolic cost of surface-level interaction. This audio waveform model demonstrates the toll of small talk, which the brain treats as high-frequency static. To counteract this, high IQ individuals adopt a complementary habit, taking long walks alone. Removing the social variable isolates the brain, allowing internal processing to dominate the bandwidth. The rhythmic, repetitive physical motion of walking, paired with complete solitude, creates the exact parameters required to enter deep thinking flow states. Within this space, the mind can wander freely, mapping connections between unrelated concepts and synthesizing entirely new hypotheses. Achieving this profound level of cognitive synthesis demands a strictly controlled physical environment, completely insulated from sudden, unpredictable interruptions. This retreat from the crowd is a biological imperative. The brain requires open, silent space to boot up its most power-intensive analytical functions. Rejecting small talk and seeking solitude act as filtration systems, protecting the brain's signal-to-noise ratio from external interference. We can now look at the complete set of behaviors: overthinking, sudden obsessions, talking out loud, leaving a desk in ruins, walking in isolation, and dodging small talk. Each of these 6 behaviors serves a specific role within a wider cognitive strategy. This macro-level flowchart maps their true function. The 6 behavioral nodes are deeply interlinked, feeding directly into an optimized architectural system. The primary directive of this system is output. It ruthlessly minimizes low-value cognitive waste to maximize complex data processing. Yet the paradox remains. If the internal system is so calibrated, why does the external output look so chaotic to the rest of the world? The disconnect lies in the observer. We are trained to evaluate intelligence based on aesthetic conformity, which blinds us to the power of the underlying mechanics. Extreme cognitive performance creates outward friction. You are looking at a machine operating at ultra-high speed. The external casing vibrates, but beneath that movement, the internal gears interlock exactly as engineered. Judging a deeply analytical mind by societal standards of neatness is like judging the computing power of a server farm by how neatly someone tied the external cooling cables. Mental sharpness is defined by the quality of the data synthesized, the depth of the variables calculated, and the speed at which optimal solutions are reached. High-level cognitive performance relies on the internal analytical architecture required for complex thought, regardless of whether the external results match societal expectations.